Recording. All right. So we are recording. We are continuing with the example that we talked about the other day, and I kind of wrote down some of the stuff that I talked about, but was never written down. So we'll continue, with in that process. And also, one particular person is supposed to come see me. I sent that person email already, and I have yet to see that person in my office. So that means, until I get that person to see me, that person will not be getting a score for the second exam. Um, I don't know, who is who in this class, so I don't think that person is actually in class right now. Anyway, but I do want it to be recording so that anyway. All right. So last time we talked about the process of actually developing programs. And I kind of talked about the top-down process, which is kind of what you need to do when you are in an English writing class, like say, English writing 300, and you need to write a relatively long essay. You kind of have to organize things from the top down. Does that make sense? Okay. It's kind of the same thing when you're planning a trip too. Okay. You don't plan the trip by, narrowing it down all the way to the minute details. You just have to go like, okay, I need to visit this person, and this person. You start with kind of like a loose overall plan, and then you kind of consolidate a little bit. It's like, okay, but before I get to this person, I might need to go to Costco, pick up something, and then go to this person, and so on. You refine the plan, as into more details, when you have more information. So writing program is kind of the same way. Top down is touted as quote unquote the only way to write programs, but that is actually not true. What top down is really good for is planning. Okay, if you need planning, the top down approach is really useful. Mostly because we use it to also break larger problems into smaller problems. Okay, it's also called divide and conquer. Okay, so there are many ways to look at the top-down approach. It is good for planning, but the top-down approach is not good for one thing, which is actually writing the code. Okay, it's good for figuring out dependency, but it's not good for writing actual code. So in the example that we have, the output is supposed to include an array called grades, where each element of the array corresponds to the letter grade of a student of a matching element of the same index in the IDs array, and value of 0 means a letter grade of F, etc. Okay, so we are not at this point too concerned about going through the entire array because we know that in order to accomplish the first bullet point that is on the projector right now is we have to have a way to convert a score into a letter grade. Okay. Now, how do I go through the entire array of students to do this or not? That is something I need to do, but right now I can focus on one little thing, okay, which is if I just start with a score, how do I assign a letter grade based on the score? So that's what I'll be focusing on. So that approach is called bottom up. So I wouldn't say it is a bottom up approach, but it is a step. Okay, you start with something very specific that you need to do, and then you start to write the code to do it. So here, I describe in order to convert the score to a letter grade, we first have to examine what is needed and not so much how to specify the logic. In other words, I'm breaking the larger problem, which has its own output section, okay, right here, the output section of the original problem. I break it down into one tiny little step where it has its own input and its own output. The input includes the score. So let's just say somebody got a 72% of a score at the end of the semester. What letter grade should that person be getting? Okay. But in order to make this logic a little bit more flexible, I am using an array of letter grade thresholds. Um, okay. well, I said letter threshold, but it's letter grade threshold, which is basically asking, in order to get a D, what is the minimum percentage to get a letter grade of a D? In order to get a letter grade of C, what is the minimum percentage? So I want to maintain that in an array instead of hard coding in the code and go like, okay, it's 60%, 70%, 80%, and 90%. Because some professors, like myself, may not want to use those thresholds. So I want to make it as flexible as possible. Is that working out for you guys? Okay. So now well, whenever you pass an array to another function, to a function, every single time you use an array as a parameter, you kind of have to think about how can the function figure out when or where the array is going to end. Because in C and C++, when you pass an array to a function, what are you actually passing? Hmm? Yeah, so if I pass an array to a function, what am I actually passing? Yes, not the entire array, only a reference to the starting point of the array. Not index, just the column corresponding to the first element of the array. Yeah, but it doesn't convey, how many items are actually in the array. So that means, you need to figure out, okay, how can the function know where the array ends? Now, there are two approaches to do this. One, which is the safer way to do this, is to say, okay, any array parameter will need to have a length to specify where it ends. So you just pass the number of items or number of elements in the array as a separate parameter. That is the best approach in C and C++. There are some other approaches, like in this case, okay, a negative value for a threshold is unreasonable, okay, it doesn't make sense. So you can always say, okay, when the threshold is negative, that means you have hit the end of the array. You can do that, okay, but it is not safe. It is not safe because if somebody forgot to end an array with a negative value, then who knows where the algorithm will stop? Okay, nobody can tell, right? It depends on a lot of things. So it is best to basically specify the number of elements as the third parameter. And then we also want to know when the function is done, how do I get the answer back, and what is the answer? And in this case, well, it's not a blackout, fortunately. There we go. So in this case, the answer is going to be an integer where 0 represents an F and 1 represents a D and so on. Okay, so in other words, I'm not using letters. I'm just using integers to represent the grade. But the integers are fairly easy to understand because that's corresponding to the GPA standard. So based on this analysis, we can now determine what we call the prototype. So you can see how I use italic in the prototype, which means it is a technical word. Okay, the prototype of a function is a technical word, and it looks like this. We have the return type, just like in a function definition, the name of the function, just like a function definition. We have a parenthesized list of parameters, just like the definition of a function. But instead of using a brace and close block of code to specify how to do it, I just use a semicolon to end it. In other words, all I'm defining here is quote unquote the interface to use the function, but not so much how the function is supposed to work. Is that okay? Are we, or should I explain the differences between the interface versus how something works? Okay. So think about a car. Okay. Think about a normal, automatic car. Okay. The interface to a person is going to be the steering wheel, so you can change the direction, the shifter, so you can park, you can go forward, and you can go backwards, right? The gas pedal or the accelerator, the brake, the parking brake, okay, and for the most part, headlamps and wiper control and stuff like that. That's the interface, okay. What about the actual quote unquote implementation? Well, that's all the complicated stuff under the hood, inside the door, or the code inside the computer, the ECU, the engine control unit. So the what is the interface. Okay. So do you, as a driver, do you need to know, how a four cycle, internal combustion gas engine work? What about the fuel injector? Okay, what pressure is needed for the fuel injector to work? Or the oxygen sensor? Okay, what kind of electrode do we use in an oxygen sensor so that it can compare the exhaust gas entering the catalytic converter and the gas that is exiting the catalytic converter to see whether the catalytic converter is operating at the specified um, level. Do you need to know all that? Nope. All you need to know is if the check engine light is on, it's not going to pass smog. Is that making sense? Okay. So this is really just that. Okay. This is basically telling you how a driver is supposed to drive the car, but it doesn't tell you how the car itself works. Okay. It doesn't tell you how the suspension works. It doesn't tell you how the engine works. It doesn't tell you how the braking system works. It just says press this pedal and then the car will slow down. Press the other pedal and the car will speed up. Okay, turn this wheel and the car is going to go in one or the other direction. But it doesn't tell you anything about, oh, but is this an electric power assist or is it a hydraulic power assist for steering? Nope, doesn't tell you anything. Is it an EV or a gas car? Nope, doesn't tell you that either. All you need to know is there are two pedals. Press on this one, the car goes faster. Press on this one, the car goes slower. That's all it tells you. So is that okay? Does everybody kind of get a more better sense of what I mean when I said an interface as opposed to the actual description of how the job is done? The interface specifies the what. Okay, what is this? And then the actual code, which is not here, which is what we're going to figure out today, is the how. So the question is the what versus the how. Yep. And when you are operating a car, all you need to know is the what, but not so much the how. Does that make sense? Okay. All right. So the most difficult part is to figure out the how. So now we are trying to work out the algorithm. The first step is to work it out by hand. Now, when I say by hand, you can have basically pieces of paper to help you, but the idea is not to use the computer, but to do it manually. Okay? So if I were to tell you this is the threshold table, 60% is the minimum that you need in order to get a letter grade of D. 70% is the minimum that you need for C. 80% is what the minimum of what you need for B, and then 90% or more is are A's. So if I just tell you that somebody got a score of 72%, okay, how do you work out what letter grade that person is going to get? So how would you answer that question? I know you guys all know that 72% is a C. The question is what went through your mind in order for you to get to that answer. hmm That is correct. Okay, so that's right. So in order to become an effective coder, developer, or software engineer, you need to be able to kind of look into your own thinking process and figure out how you got the job done. There's multiple ways to get the job done, but you have to describe how you do it so that you can describe it to the computer. Because what an algorithm really is, it's just instructions. but it's instructions that are very specific for the computer. Is that making any sense? Okay. So would you be able to describe how to do this to another person? So you need somebody to help you because you have a whole class and there are 200 people you need to do this. And then you have four people who can help you. So now the question is, can you describe the process to assign a letter grade based on the score and also this particular threshold table to another person so the other person can help you get the job done? Okay, what do you think? It's going to be what? Hmm. Hmm. Not that much different. If you can describe it to a person, we can look at those descriptions and say, okay, if you see this kind of phrase, it means you need to do this and so on. But the first thing is, to describe the process. Okay. Okay. All right. What about the rest of the class? What do you think? Once you know how to do something, how well can you describe that process to another person? Okay, do you have positive experiences of, yeah, I think I'm pretty good at doing this, because I describe a fairly complicated process to my friend in order to do something that's kind of complicated, and it seems like that your friend does not have a problem following your instruction? Or do you have the experience of, yeah, I tried to describe something, how to do something to another person, and somehow the other person is not getting it. So, so so what do you think? What is your experience? I'm trying to get you guys to think about, how well can you describe how to do something when you know how to do it already, but how do you describe it to another person? Forget about programming, okay? We are not talking about, syntax in C and C++ and variables and parameters. I'm talking about just talking to another person. Teach the other person how to do it. Okay. Let me describe something that you guys already know how to do, but I want you to think about how do you describe it to someone who may not know how to do it yet. Okay, so let's just say that I have 20 index cards, and on each index card there's a number, so basically from 1 to 20, and then I shuffle the index cards. Okay, so they're all out of order, and I want you to sort the index cards again so that they're in increasing order, so I can see 1, 2, 3, 4, 5 all the way up to 20. Do you know how to do that? Hmm? Yes. Okay. Okay. So let me ask you this. How confident are you to describe this process to another person so the other person knows exactly how to do it? All right. So what do you need in order for this to be effective? In order for you to communicate how to sort 20 cards with numbers on them to another person, what do you need? Well, yeah, yeah, I know you guys don't know how to do it already, okay? The question is in the description to somebody else of how to get the job done, what is needed? Be very specific. Okay, that's good. That's important, okay? Okay, yep. Instructions and okay, so what quality of instructions do you need? Because there are different qualities in terms of instructions. Very okay, very good. Step by step, okay? Sequential, okay? So sequential and very specific. And then what else? Mm-hmm. Well, those are the two most important parts. Okay, so let's go ahead and check out, whether, we can do this, with specification, with good specification, and also, do it really step by step. All right, so this is how I might describe it. Okay, so the way I would describe it is start with the lowest possible grade, which is an F. Okay, so I didn't write down start with. Okay, but you start with the lowest possible grade. So start with those two words is really important because it tells you that don't do anything else. Okay, start with this. Okay, so that's part of being sequential, step by step. Okay, you're now saying this is the first step. Okay, you don't do anything else, but do this first. And then compare the given score to the left column of the table. So this is being more specific. I'm not just saying compare the score to threshold. Okay, so because what threshold are we talking about? Well, the thresholds are the left column of the table. Okay, that is specific. Given score, okay, is the score that you're given with. So that is also specific. And one thing I did not do very well is starting from the first row. So you don't start from the bottom and work your way up. You have to start from the first row and then work your way down. That I did not specify. Okay, so I was not being very specific in that case. If the given score is greater than the threshold, move to the next row. So I look at 72, I compare that to 60%. 72 is greater than the threshold of 60%, I move down to the next row. And then I compare 72% to 70. 72% is still greater than 70. I move down to the next row. And I keep doing this until, oh, wait, no, that is, keep doing this until one of the following happens. The person is now has a letter grade of A because that's the highest possible grade, so we can stop there. The threshold is larger than the score. So in this case, the threshold of 80% is larger than 72%, so I can stop here. But the person is not getting a letter grade of B because the letter grade of B is just out of reach from the person who has a score of 72%. So I have to kind of roll back to the previous row and say, okay, so the grade of that for that person is a C. Is that kind of okay? All right. So once we have the description like this, then we can start to think about how we are going to put this into C++ code, which I think for beginning programmers, this is the step that is the most difficult. Unfortunately, it is also very difficult for someone who knows how to code already to describe the process. So I am going to try my best to describe the process and you guys can comment on which part is not clear, and then I will try to clarify the thinking process. In other words, the algorithm that we're going to end up with, is actually the least important part of today's lecture. It is the process, the thought process of how to get there that is more important. Okay? All right. So the way I normally teach people to do is to think about all the things that we have learned. Okay, think about control structures and what we have. So we'll just go ahead and just write in English right now. So what is given to us? So what is given to us is a score to be converted into a grade. Okay, that's given to us. Um, an array of thresholds to letter grades and also the number of thresholds. Okay, so those are given to us. And sometimes it's good to refer to these by variable names. So the score, we can just call it score, we can call it given score, either way is fine. So we'll just say this is called given score. So I am assigning names to the various items right now, just so that I don't have to kind of rewrite the entire sentence like this. So now we have thresholds. Okay, so thresholds is actually not a bad name for an array. And because this is the number of thresholds, I personally just use num thresholds. Some people use length and so on. I mean, you don't. Whatever you do, just make sure that the variable name tells you what it is for. Okay. All right. So this is what we're given with. So now you have to think about all the things, all the control structures that we have learned in this class. A control structure is essentially a statement that will, well, yeah, so it has certain elements of saying, do we do this? Do we go this way or the other way? Okay. And there are three control structures that we have talked about in this class. Okay. The three control structures, one is a conditional statement. Starts with if. The other one is a while loop, which means you ask the question first, and then if the question answers, it comes back with an answer of true, then you perform one iteration, but then you go back and ask again. We also have do while, which means you do something without asking a question, you do it first, and then you ask the question of should we do it again? Okay, so that's a do while. So the importance of remembering that we have three control structures is to think about the task that we're given with. You go like, okay, so which one do you think is needed? So what do you think? What control structures might be helpful in this case? Okay, aha. So I like what you're talking here. So we'll just kind of put that in rough form here. So now you're saying, okay, if given score is what? Okay, so we're comparing it to a threshold. Okay, all right. So we can be pretty loose here. Okay, so threshold with some kind of indexing. Okay, all right. Okay, that's good because when I described the process, I did mention that give compare the given score to the threshold if the score is greater than the threshold, blah 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 blah. Right? Okay, okay, very good. What else? What else do you think is a useful control structure in this case? One good question. Yeah, go ahead. I don't know why the light is playing tricks. Mhm. Okay, I'll try another approach. The only reason why it might be turning off is probably the sensor not detecting motion. And the sensors are those little dome things, and they are detecting motion because I can see the LED is on. So it's not because of the lack of motion or it's not detecting it. So there's another reason why it keeps turning off the light. Anyway, getting back to this problem here. So what other control structure may be helpful? Yep. Okay. Well, okay. We'll throw that in. Okay. So yeah. So when we think about a conditional statement, we can also think about, but what if it is not greater than the threshold? What do we do? Okay. Okay, that's good. What else? Okay, let's look at the description here. Okay, we say over here, keep doing this until blah 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 blah. So what is that suggesting? A loop of some kind, okay? But at this point, I don't know what kind of a loop we are talking about. It can be a while loop, it can be a do while loop, but we know it's some kind of a loop. So I'm just going to throw a loop here, and I will even say loop until one of the two conditions, right? So we say, a letter grade of A or the threshold, okay, thresholds, blah, 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 is greater than the score. That means we can stop. Okay, very good. And you can see that, this is so loose. I mean, this program is not going to compile. But that's okay, okay? We are just kind of this is top down, okay? Top down means we are looking at the dependency. We look at the description in English, and then we are just saying that, well, okay, that in English means we probably need a conditional statement. That in English means we probably have some kind of repetition, which means some kind of a loop. We don't know how everything is going to be organized. We just kind of throw things together right now. Is that okay? All right. But what this also means is you have to be fairly familiar with what control structures are available to you, what they can do, and how that maps to the English description or whatever language you decide to use. Because we can see that if is matching the exact word of if here, right? That's the English description. And then the loop is a little bit hidden, okay? Because it says, keep doing this, blah, 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 until, a condition. And this part here is really the conditional part, which is like saying, okay, if this is still, if this is not true, go for another iteration, right? Okay. There's one more thing that is hidden in the description that will tell me that I also need something else. Okay, so if I go back to the description, we also have one more concept that is important. It is not a control structure, it is the concept of variables. In other words, you can have as many local variables as you want. Okay, in addition to what is given to you, you can say, oh, I'm going to need like 5 little post-its everywhere so that I can complete the task, and you can have as many post-its as you want. Those are variables. Okay, so now if we go back to the um, algorithm, what do we need to keep track of? Okay, because variables are basically constructs that can let you keep track of something. So in addition to the given score, which is given to you, okay, so you don't have to make that little piece of paper. What else do we need? Okay, let's read the instructions here. I said right here, if the score is greater than the threshold, move to the next row, or compare the given score to the left column of the table. And when I compare to the left column of the table, I can only compare to one number at a time. And then there's also this phrase here, which is move to the next row. So that means I need to keep track of which row I'm on. Does that make sense? Yes, go ahead. To move down. Yep. Yep. But the importance is we need to keep track of it. Okay. There are different mechanisms to keep track of quote unquote which row we are on. For this class, we're going to use indexing. No other way to do it for this class. But when you move on to 360 and 400, we can use pointers, and there are many ways to do it. But the idea is we need to keep track of which row we are on, right? So that we can say move on to the next row when it is time to move on to the next row. Okay, very good. So um, so in the actual code, I say, okay, we need to keep track of which row we are on. So we're going to say row number, okay, as a variable. Okay, is that okay? All right. So I'm now moving on to the next revision. I'm just going to use a bunch of dashes here to separate this from the other one, from the previous version. All right. So when we have multiple control structures, one is a conditional statement, the other one is a loop. Um, hmm, which one is containing which other one? There are several ways to do this. In other words, am I saying, if this something, then keep doing this until blah, blah, blah? Or am I saying, okay, this is the kind of stuff that you need to keep doing, until blah, 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 but that entails a conditional statement. So the first or the second, is the conditional statement containing the loop, or is the loop containing the conditional statement? How are things supposed to be nested? Yep, that's right. Because for each row, we have to evaluate the if. We start with the first row, okay? We go like, okay, is that true or not? If it is true, then this is the grade that person is going to get. If not, move on to the next row. Okay. All right. So that means we are going to have something like this. Okay. Loop if, okay, we don't know what this is going to do. Okay. But we know that we have to compare the given score to the thresholds somehow. Okay. And maybe there's a if else. And then the until is a letter grade of a, or thresholds blah 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 is greater than the given score. Okay. All right. Well, this is big. Okay. This is big because now not only do we know that we have repetition of some kind, we have conditional statements of some kind, but we also know, which one is containing which other one. Now, it turns out that later on we can completely remove the conditional statement, but we'll deal with that later. Okay, so what do you think needs to go into the dot 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 here? In other words, the dot 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 inside the square bracket, what does it do? What is the whole purpose of the square bracket thing? Hmm? Grades, okay. So what is thresholds again? It it is an array of real numbers, okay, or percentages, okay? It's an array. So if you have an array called thresholds and then you use the square bracket, what are the square brackets doing? An array is a bunch of stuff, right? So the square brackets will is called indexing, okay? But what does indexing actually do? Hmm. What is the purpose of the index? Aha, very good. Okay, I like that word. Is to choose one element out of all the elements of the array. Very good. Okay. So now that we know what the square brackets are for, it is for us to choose one of the many thresholds to compare to. Because you cannot compare to a bunch of numbers at the same time. You can only compare to one number at a time. And thresholds is a bunch of numbers. So the square brackets would allow you to go like, okay, we are only comparing to this one here. Do we have a name for that thing that helps us keep track of which row we are focusing on? Okay, let's look back. Row number. Very good. Okay, so now we are going like, oh yeah, I forgot about that local variable called row number. The whole purpose of row number is to keep track of which row we are supposed to be looking at. Okay, so now I have resolved the dot 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 inside the square bracket to go like, yeah, that's exactly what row number is supposed to do. Okay, cool. Okay, very good. But you can see how the algorithm, is I do not write the algorithm sequentially, like, okay, just line by line, bing, 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 done. Okay, I go by structure. Okay, so this is how I work. This is how my mind works, is it has to work on the structure. Okay, what is containing what else? Okay, and what do I need at each level of the control structure? That's how my mind works. Now, how does your mind work? I have no idea, but you probably want to kind of explore how your mind works. Okay, try to solve a problem and then observe yourself. I know it is difficult because part of you is trying to solve the problem, and then the other part of you is trying to observe yourself solving the problem. Okay, but I can tell you, once you go through that process and you know how to do it, it's actually really helpful. Yep. Okay. So what else do we do now? Okay. So I'm going to put some dashes here. Okay. So let's go, check out. We can now refine this a little bit more. Okay. So the first thing we can refine is to say, okay, what are we actually doing here to do the compare? If you go back to the English description, it says if the given score is greater than the threshold, then we can kind of move forward to the next row, right? Okay. So that means we can kind of borrow that and say greater than. And then the then statement, okay, is going now. Right now, this is not C syntax, okay? This is just using indentation to tell me, okay, what do we need to do if the given score is greater than the threshold? I think in the English description, I said move on to the next row, right? Okay, and how do we move on to the next row? Row number is an index into the array, which means it starts with a value of 0, and then the next row has a value of 1, the next row has a value of 2, and so on. Increment, what do we increment? Row number, very good. And how do we do that? What is the way to specify that? Okay, so is it just this? That calculates, right? So row number plus one is not adding one to row number. It is just calculating what is row number plus one. What do we need to do with it? Wait. Okay, let's move back a little bit. Okay, row number plus one gives me row number plus one. So if row number is currently zero, row number plus one becomes one. But does that do anything to row number itself? It does not change it. There's only one operator that can change something. What is it? What does it look like? Assignment, that is correct. But what does it look like? It's a single equal. Okay? So that means don't forget, okay, that you need to change row number itself using an assignment. We are not changing the array. We're only changing which part of the array we're looking at. So row number just tells you, okay, we're looking at this part of the array. Yep. Okay, cool. Um, so what about else? Do I have anything specific to do for the else? Go ahead. 72. Mm-hmm. Mm-hmm. Well, we can handle that later because all of these are being done in the loop. So I think the for the else, there's really nothing to do because we have already gone as far down the table as we can. So the repetition part is done. Okay. So the else part is, we really don't have anything to do. So I'm just going to say, yeah, question mark here just to emphasize that I suspect there's nothing that we need to do. But whether that really is the case or not, remains to be seen. So we are open to maybe there is something to do, but right now I don't think so. Okay. So you can see how this process is kind of fuzzy in a way, but in the fuzzy process, I'm trying to make the code as specific as possible. I'm increasing the level of being specific in the code while going through a somewhat fuzzy process in my head. Okay, all right. So let's go back here. Okay, so how do I know somebody has already achieved a letter grade of A? So let's scroll back on the other side to the table here. So how do I know somebody already has a letter grade of A? So in this case, think, right? So one way, okay, I should probably write it down at some point, is to give yourself examples, okay? If it is difficult for you to think in an abstract term, in variable names and arrays and indexing and loops and conditional statement, just give yourself a concrete example, okay? Somebody got a percentage of 95, okay? So you would say, okay, if I follow my own logic, okay, we start with the F, okay, and 95 is greater than or equal to 60%. So that means, it's good. Okay, we should move on to the next one. 95% is greater than 70%. Cool. 97% is greater than 80%. Cool. 95% is also greater than 90%. Cool. Oh, wait, I just moved out of the entire table, right? So how do I check for that? In other words, we have nothing else to compare to now. So what is the condition to say that I think this person is gonna get an A, okay, because this person has exceeded all the thresholds in this table. How can we tell? Okay, so what do we need? Okay, so the way I think is start with what do we need to get something done, and then I'll try to figure out how to use that to get the job done. Okay, but I first think of what do we need to get the job done. So I go like, nope, more than that. Nope, more than that. Nope, more than that. Nope, more than that. What is my finger? What is the code that is representing my finger as I move down the row? Row number. Row number. Okay, so we know that a letter of A, or we have exhausted every single row, has something to do with row number compared to something. Okay, okay. Well, and what is so in this case there are four items here, right? This is index 0, index 1, index 2, index 3. So by the time row number becomes 4, I go like, oh, we don't have anything to compare to anymore. Let's get out of the loop, right? So what do you think that 4 is in terms of the variables that we already have and also the parameters of the function? Okay, so if we cannot remember all the functions or all the parameters, let's go back here. There is something here that we haven't used yet. There's one parameter that we haven't used. Given score, yeah, we're using it all the time, right? Thresholds as an array, yeah, we're using it all the time too. What about the third one? Num thresholds. Have we used num thresholds yet? And what is it representing? The number of thresholds in the table, right? So in this case, in this particular example, if I were to convert the table into an array, how many items are in the array? Four, right? And the index or the row number starts with 0 and then goes to 1 and goes to 2, goes to 3. And when it gets to 4, we go like, we're done. And 4 is num thresholds, right? Okay. So I think we know what we need to compare row number to. I think we need to compare that to num thresholds. Okay. So now we just have to decide in order to stay in the loop, because that's what until is implying, right? Now you can say, but tech, we don't have repeat until loops in C and C++. Yeah, I know that. We can fix that later. Okay, we focus on the logic of the thinking. We leave the syntax and oh, C doesn't have this or C has a better way to do this. We leave that all to some later point. Okay, we get the idea across first, and then we focus on okay, you need a semicolon here. You need a comma over here. Okay, that's minor details. Okay, we leave it to Grammarly. Okay, but we focus on the idea. So the question now is, um, what should this be? Okay, so you can think. So once again, you bring out your dictionary. Okay, what are the 6 ways we can compare things? Less than, greater than, less than or equal to, greater than or equal to, and not equal to. In other words, your choices are finite. So now, if you're new to this, it's okay. Okay. You just plug in one of the 6 at a time and ask, does that make sense? Okay. So we'll start with things that do not make sense. Okay. Um, not equal to. Well, not equal to obviously is not going to make sense because you start at row 0 or row 1, okay, and by the time you get here, num threshold is not going to change. It's going to be 4 all the time. So not equal to does not make sense, okay? Equal to, actually, quote unquote, makes sense here, but um, it's not the best choice, okay? Sorry? Greater than or equal to is the best choice, okay? So we'll go like, so when row number is greater than or equal to num thresholds, we should get out of the loop. Because when row number is greater than or equal to num thresholds, guess what? Row number cannot be used as an index anymore. Because in the table here, in this particular example, this is at index 0, index 1, index 2, index 3. So when row number is 4, we don't have an item corresponding to index 4. So that means row number is not even a valid index at that point. So we should get out of the loop as soon as possible because we're done. There's nothing else for us to do. Is that okay? All right. Um, and then over here, I think we can just kind of keep that, when thresholds row number is greater than the given score, and then we go like, yeah, not given score. That'll be your homework assignment. But given score is um when the threshold is exceeding the given score, then we go like, we can move down another row and try again. Well, we don't actually need that, okay? Because we can. So this part is a little bit icky, okay? Because by the time we get here, this plus one is already done. Yeah, it would still be fine, I think. If given score is greater than thresholds, and we increment if it is, what if it is equal to? So if it's equal to, we are not going to increment, which is going to cause problems. So we have to keep the same condition. So I think that's better. Okay, we'll test the boundary cases later. Okay, we'll call this a major step in the derivation of the code. All right, so we'll copy and paste again. So this time we look for other things to refine. There are a few things we can do to refine it. For those of you who want to go to like, I want to focus on the syntax, we can do that. Okay, so, but before we want to do that, we still have to answer the question of what kind of a loop is this? Is this a do while loop or is this a just a while loop? In other words, okay, there's one more thing. Okay, let me roll back because yeah, go ahead. Okay. Um, row number never got an initial value. Okay, the only way that we update row number is to say whatever it was plus one, right? But it never started off with a particular value, so we kind of need to initialize row number. And that initialization has to be done outside the loop. So that means it has to be done here, which means we have to say, okay, row number is going to start with a particular value. And what would that be? Start with zero. Okay, very good. So start with a zero. Okay. So if it starts with a zero, then we go through this loop. So now the question you have to ask yourself is if what if somebody has a score of 40%? 40. Yep. So that person is supposed to get a grade of F, right? Which means row number should be 1 so that we can roll back a little bit. So that means, so we follow this logic here and ask if the given score is 45%, then the first iteration is going to compare if it is, if we perform the body of the loop. So given score is going to be greater than or equal to the threshold of row number. That's going to be false. So we're not going to do this. And then we'll get to this part here. Row number is greater than or equal to num threshold. It's going to be false because row number would still be zero in that case. But thresholds being greater than given score is going to be true. So we exit the loop. Okay. So it is okay to have a do while loop in this case, or at least the way the logic is expressed here, it is okay. So that tells, so are you guys following the logic here? What did I do? I give myself examples to evaluate, okay? Because in the process of evaluating a particular specific case, I can go through this logic and see whether it works or not. Now, if it doesn't work, then I can tell, oh, okay, it's not working because it's not supposed to go here. Then I can try to figure out a way to correct the path. But in this case, it seems to be okay. So that means at this point, I can kind of go like, okay, this is going to be a do while loop. Do blah, 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 and then a while. Okay. But the problem with a do while loop is you have to reverse the condition because in the repeat until, you keep looping until the condition is true. But in a do while loop, you keep repeating until the condition is false. So that means we have to invert the entire condition. So I'm going to use C syntax here. That's C for not. So we have to invert it. Let me just pause here and see if there are any questions about why I put a negation here. Does everybody understand why we have a negation? Because I converted from repeat until to do while. That's why it isn't. That's why we have to negate the condition. Okay, so if you're not understanding that, that's okay. What you need to think of is an example. Okay, so let's just say that you have somebody who's younger and you don't want to do the dishes, and there's someone in the household who's younger, and you go like, okay, I think I need to tell that person to do all the dishes, right? So the instruction is uh, repeat, wash, rinse, and blah blah blah. Basically all the process to do the dishes until all the dirty dishes are done, are gone, right? Until all dishes are clean. Okay, so that seems like a reasonable way to express that logic. Now, whether it's reasonable to pass on a tedious chore to somebody else, that's a different question that cannot be answered in a programming class. So if you were to change the instruction to as long as, okay, because while is basically as long as, okay. So what are you going to say in the case of as long as? So you keep the whole process of, use soap, okay, rinse, dry, blah, 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 as long as what? As long as not all the dishes are clean, right? So that means the logic or the condition is inverted. Repeat until and as long as they need opposite logic to express the same steps. Is that making any sense? Okay. And that is why we have a negation here. So this negation here is because we converted from a loop until to a do while. Okay. All right. And now we can also, just kind of throw in the correct C syntax here. Okay. We'll just be a little bit more specific. Doesn't look like we got anything else to do over here. We just get rid of it. All right. So now we seem to have, the loop logic here, but the loop logic is not going to work entirely because somebody who has an A or somebody who has like a 95% is going to exit when row number is greater than or equal to num thresholds, but I'm supposed to return a GPA in this case. In that case, the GPA actually is correct. Returning 4 as a GPA is actually correct. So now we have to double check, and this time we have to check the boundary cases. Okay, so if you don't know what is boundary case, what boundary case means in programming, what do you think it means? So guess, give me a guess of what boundary case means. So let me give you an example. Okay, in this particular program, um, is 70% a boundary case or is 71% a boundary case? 70, okay? Because 70 is right on the edge of transitioning from a letter grade of D to a letter grade of C. 71% to 79% is like, yeah, it's right between these two. So there's a whole bunch of them and they're not boundary cases. So boundary case means it is right at the edge of, oh, we just is it going to move this way or is it going to move this way? It's right on the edge. So those are the ones that you need to test, okay? Because a lot of times, if you specify greater than versus greater than or equal to, should we add one or not add one? They affect the boundary cases, okay? You can get everything right, but the boundary case wrong. So now we want to double check, is the boundary case going to work? So we'll just say somebody gets exactly 70% as a score. Is this code still going to work? I'm not going to do a full trace, so I'm just going to talk about it. Row number starts with 0. Okay. 70% is greater than or equal to 60% is true. We increment the row number, so it moves on to row 1. And then by that time, we get to the while condition, which then specifies is 1 greater than or equal to num threshold? No. Or thresholds 1 now. which is 70% greater than 70%. This is a no. So that means it is going to exit the loop. Okay, which seems to me it is the right thing to do. Let me check again. This is the whole thing is negated. So row number is greater than or equal to the number of thresholds is false, but because this is an or, we have to evaluate the right hand side, which is threshold 1 because we just added 1 to it is greater than given score, which is also false. So we have false, but then we also negate that. False or false is false, not false is true. Oh, we are not exiting the loop. Let me double check. Yeah, we are not exiting the loop here. So I made a mistake somewhere. Let's see. I'm rolling back to the previous one, but this is also an important step. Okay, you have to kind of mentally test the code out. Okay, in this case, I'm testing it and it doesn't work. So we have to roll back to this one and go like, okay, until row number is greater than or equal to num threshold, this is not true. Or threshold row number is greater than given score. So it's zero point 0.7 greater than zero point 0.7. This is also false. So until false, so that means it is continuing with the loop. So the problem with this is this condition here. So we have to say the given score is, no, that looks right to me. What am I getting wrong? Hmm. We need the threshold to be greater than, because that's the grade that this person cannot get. In this case, 70%. Okay, so that means we have to, the row number is a 1. Okay, spell typo here. Row number is 1, so thresholds 1 is 70% or zero point 0.7. Zero point 0.7 is greater than zero point 0.7 is false. So we have false or false, which is false, but not false is true. So we go back to this code here. Okay. Oh, okay. I, it is fine. We go back to this beginning here. Then it goes to zero point 0.7 is greater than or equal to zero point 0.7. That is still true. Row number gets incremented. So now we are looking at the zero point 0.8, and that time is going to exit because zero point 0.8 is greater than given score is going to be true, and true is inside the OR, so that means the whole OR is true. But because we negate the whole thing is going to be false, then we get this out of the loop. So I was confusing myself. The code actually does work. And an OR, by the way, is a double bar. Okay, so when we get out of the loop, okay, all we need to do is to return row number because that is the equivalent GPA in this case. All right, easy. Are we doing okay so far with this? All right. So we cover all the boundary cases, okay? Now, can the code be simplified a little bit? The answer is actually yes, okay? But the way that it is right now does work, and the focus here is, how do we go from the beginning, all the way to the end? Now, let's say we are done with this, okay? So now we actually write the C code, okay? So we put a whole bunch of dots here, okay? So because I want to give you the actual code, so now we have to refer back to the prototype, okay? So we refer back to the prototype because this is how the whole function definition should start with without the semicolon, okay? So without semicolon, instead we have a block here, and inside the block is the code that we have just figured out. Okay, let's do a Control C, Control V, and then we are gonna need local variable row number. So this is how we define a local variable, and just gonna indent everything else just so that the nesting is correct, like so. All right. So I have a suspicion this works. Can I test the program? Can I write a program just to test this? Or in this class, can I trace it with specific examples to make sure that this is working? Well, let's find out how to do this. Okay, so that would be actually be important. So now, and this is also the main reason why bottom-up coding is really helpful because you can test things out, as soon as you're done with one step. Okay, so main is the entry point of the entire program, right? So we are actually writing code. So we start with some kind of a local variable x, okay, and then we say the thresholds. Okay, so int, oh no, double thresholds, and we are going to use the usual actual thresholds, which is zero point 0.6, zero point 0.7, zero point 0.8, zero point 0.9. Hmm? Double? Okay, we kind of talked about this last week a little bit. So the double is kind of like a type, like int, it is a type. X is an integer, so it can only store 1, 2, 3, 4, 0. But a double is what we call a real number, which means it can store 3.1415 and so on. It can store zero point 0.6, it can store zero point 0.7 and so on. Because an integer cannot store numbers like that or values like that. So a double can do that. Okay, all right. So now what we'll do is to say, okay, we'll test the program or the function that we just wrote, score to grade, and we'll test out, some non-boundary case. Okay, let's say zero point 0.3, and then we give it thresholds, which is the array, and then we say we have to tell it how many items are in thresholds. In this case, there are 4. And then when x comes back, when x gets a value, then we get to compare. Are we getting 0? Okay, because zero point 0.3 as a score should get a GPA of a 0 because it's corresponding to an F. You can also test this with boundary cases. Okay, 0 itself is a boundary case, but I don't think that's going to be a very exciting one. It worked fine. The more interesting boundary cases is let's say zero point 0.7. Okay, that would be a really boundary case. It should come back with a letter grade of C, which is a 2. Okay, and so on. Okay, so this program can be traced by hand. It can also run in a debugger so that you can actually see how it turns out. So we still have some time. So I'm going to introduce the concept of a debugger because that is something that most professors do not teach in CISP 360. Okay, in this class, a debugger is not very useful, but in order to test this code, I can trace it, which is going to be very tedious, which is still useful. But instead of doing that, I'm going to use a debugger. So this is something you don't have to write down because we are not using actual debuggers in this case. Um, Let me see. Should I use the online one or should I? Yeah, I'll just use online GDB. So there's a website called Online GDB, which allows you to copy and paste code into here, and then you can just kind of test run the code to see whether it works or not. So this is the code that I'm pasting into here, and then you specify the language. Okay, this is just regular C, and I say debug. All right, and it found some syntax error because we don't have Grammarly for C. It says on line 5 of main, it has a problem because I think I pasted twice. Ah, okay, that was my fault. No wonder the program looked a lot longer than it should be. There we go. So I just deleted the other half and we'll try debug again. Given score is undeclared on line 5, which is here. This given score is undefined because I named the variable score. Should have used given score. There we go. There we go. All right, so debug again. Yep, this time it compiled. All right, this is kind of somewhat beyond the scope of this class, but it is a useful skill for you guys to have. So these are called breakpoints. So a breakpoint means when you run this program, it will it will pause at where the red dots are. The way you set a breakpoint is simply to go to the left-hand side of a line number and then single click it. If you click again, it goes away. So this breakpoint we don't really need. We just need 3 breakpoints here. So when we get to the line 16 breakpoint, it would have executed line 15 already, and x should be a 0 in that case. When it gets to the next breakpoint, line 16 would have executed, and in that case, it would still get a score of 0, I mean a grade of 0. When we finally get to the return 0, x should be a 2 because a 70% is going to be a letter grade of C, so that's what it should be receiving. Okay, so now we're going to test this code and see if it works. And the way to do it is simply to run it. Okay, I'm just going to type run in the GDB console, and now it has reached line 16, which means line 15 has executed already. And I can say, okay, what is the value of x right now? It is a 0. So is that correct or not? In other words, given a score of 30% and given these are the thresholds to get a DCBA, are we supposed to get a an F right here with that score? Is 30% getting an F? Okay, cool. So that works. Continue. Now we get to line 17, which means line 16 has executed. I think most people will agree that, okay, this one should be pretty easy. X should also be 0 in this case. Print X. It is also a 0. Very good. So this is the last one, which means line 17 has executed. And X should be, it should be a 2 because uh, everything that is less than a zero point 0.6 is an F, which is a 0. Everything from zero point 0.6 all the way to 6.6999999 is supposed to be a 1 because that's a D. Everything from zero point 0.7 but just less than zero point 0.8 should be a C, which should give me an integer value of what? 2. That is correct. So let's double check. Okay, so we now print X. It is indeed a 2. There's one more case that I should check, but I haven't checked yet. So I stopped the execution of the program. And the last one that I really need to check is um, check score to grade, someone who's supposed to be getting an A. So we'll say 0.95, which is 95%, thresholds 4, and put a semicolon here. So this time I can focus on just line 18, which means I put a breakpoint on line 19. So we debug the program, run the program, print X, it is a 4. Okay, so this is me being super lazy, not hand tracing everything. Okay, but in this class, I need you guys to hand trace everything because I need to make sure that you can follow the logic by hand. Why do you think that is important? Say again? You should be able to follow your own logic, right? So that means this is also why, I really focus on tracing because, someone who does not know how to trace the execution of a program probably will not be very successful in the next class. Go ahead, sorry. hmm It, it would be the equivalent of hiring a contractor, okay, and you go like, okay, contractor, I need you to put a electrical outlet right there, okay, and the first thing the contractor needs to do is to saw a hole on in the wall so that you can he can mount the he or she can mount the electrical box and so on and so forth, right? So what if the contractor reaches into the tool bag or at the back of the truck and go like, pick up a tool and go like, I'm not really sure what this is, but I'm gonna try that out in your house. It turns out to be a demolition hammer. Okay. Do you want a contractor like that working on your house? Nope. You want a contractor who reach into the tool bag and go like, okay, I need to cut a hole in drywall, okay, and I need straight lines, and this is going to be the right saw for this purpose, okay. Not only the right tool, okay. This is the saw blade that I need, and double check the saw blade has really sharp teeth so that it doesn't tear all the tear up the board and so on. And that's why I need to make sure that you guys can follow the code yourself, okay, in the traces. That is telling me if you can do this, that means at least you know what is in a tool bag, okay? Because until you know what exactly is in a tool bag, I cannot trust you to use those tools to do anything. Is that making any sense? All right. So we are almost running out of time. I will post this program so that those of you who want to go like, okay, meanwhile, what am I going to do? Well, trace it, okay? Not the entire code because it does get tedious. I'm just going to say trace the last one, okay? Get rid of these, the first three of these, and just trace the last one. Let me just fix this up and I'll post it in the announcement. This is not a homework assignment. I'm not going to grade it. Okay. Does it mean it's not important? No, it is still important. It just means that you have to do this as a way to study for the final exam. And then on Wednesday, I'll talk about how the final exam is going to go. Basically it's just going to be similar to the last few homework assignments, okay? But I might make it so that you don't have to do the entire trace, which is super duper tedious. So I might do most of the lines, the rows already, with certain ones missing. So your job is really just to fill in the ones that are missing. Okay, so that would kind of cut down the amount of time that it needs in order for you to really write a lot of stuff, on the in the answer. You just have to go to the empty ones and go like, okay, what is supposed to come here to get here? All right, so I'm going to copy and paste this into a text editor, and we are done for today's lecture. We have one more lecture to go before we get to the final exam. So if you need some additional help with the concepts to explain things, or need some help to understand how to study for the final exam, I have office hours. Okay, I have yet to see. Well, okay, I cannot say that. Um, but not too many people come to my office hours. Okay, so I think it is a resource that some people have not used. So it's up to you to decide whether you want to come take a look or just come to my office hours so that you can ask me questions. But other than that, we're done for today's lecture. I will see all of you on Wednesday, and I will post this in the announcement just so that you guys can get to it. hmm Uh, it's already passed. It's from 8 to 9, it's right before the class. But I'm usually in my office. If I'm in the office, you can still come in and talk to me. Paste. There you go. All right.